Hello, this is Mr. Bedford going through exercise 11b question 5d. Now, on this particular question, we've been told that vector c is equal to this and vector d is equal to this. Notice that in my working out, I won't be underlining the vectors because it just looks too confusing on this type of working out, but it's what you're expected to do. So let's have a look. Here we've been told d take away t lots of c is going to be parallel to a given vector, and we've been asked to find out the letter t for that. So my first job is to substitute in for the values of d and c using the above bit here. And if I do so, I get this. Here's my vector d, take away t lots of vector c, and a nice bit of expansion allows me to get this negative 3ti minus the 4tj, and finally a bit of factorising to separate the I and the j components brings me to this bit here. Now at this point I just want to double check I've not made any mistakes. So negative 3t times the I brings me that term, the 1 times the I brings me that term, the minus 4t times the j brings me this bit, and negative 2 times the j brings me that bit. So I've got all my bits in order there. I can now have a look at trying to use this parallel bit of information. So they said that this bit here is parallel, and they gave me the vector minus 2i plus 3j. So what does that mean? That means if I took a point, say here, and I went negative 2 in this direction, positive 3 in this direction like this, I join the nose to the end there, and I'd get this negative 2i plus a 3j. And if I now look at my other vector, the one which I've worked out here, this one here, which is this d minus this take away t lots of c, that vector is also parallel to this one. And what I can see from this bit is that this angle and this angle are equal to each other. If I use this part of the equation, I can say that tan of theta, thinking back to our good old days of trig, the opposite over the adjacent, will be the 3 divided by the negative 2. And that's got to be the same for the tan of theta for this bit. But this horizontal part is this bit here, the negative 3t plus the 1. Scrap that. I need that to be the opposite side at the top, don't I? So the opposite side from this one is this side here, which is this j bit, the negative 4t take away the 2, and that needs to go over the adjacent side, this side here, which will be the I vector, the minus 3t plus the 1. And that's the equation that I can look at solving. So, one that's been done earlier. This was equal to tan of theta. Solve this by cross multiplying, gives me that step. Expand away gives me that step. Separate the t's onto one side and solve for the value of t. So what that allows me to do then is simply work out the value of t. That's how that's done. Now what else can I add to that one? If you look at the answers now, the answers or the worked answers that you can get bring you in at this stage here. And what I was seeing was no justification as to why you could get that step. I was just seeing it being stated and written down. So hopefully you got some justifications for that. The other thing I would like to point out comes back onto this side here. Now, if I try and sketch roughly in, shorten that bit like that, just so I can get the drawing in. This part was my I bit, the negative 3t plus the 1, and this bit was my j bit, which would be this bit here, my negative 4t minus the 2. The reason you can't equate the I and the j vectors in this case is that this length here is not the same as this length here. So that's why we can't say that this negative 2i is equal to this bit here and try and solve it, and it's why we can't say that this bit is equal to this bit here and try and solve it. In fact, if you did, A clue that you were doing the wrong thing would be the values of t would come out to be different in both of those cases, and we're aiming to get just one value of t. Right, hopefully that helps.